Hi everyone, welcome back to Daily LeetCode. So today we are going to solve this problem. It's LeetCode problem 2213, longest substring of the one repeating character. Okay, so this problem look a little difficult at first, so let's completely ignore the complicated wording and understand it with simple example. So let's go. So we are given a string. See, in this problem we are given a string. Yes is a string. Okay, first let's understand what is this. So first we are given a string. For example, s is equal to a b b c c. Okay, so now we can look at its character like this. See, each character has an index 0 1 2 3 4 5. Okay, each character has an index and the indexing starts from 0. So index 0 contains a and index 1 contain a, so index 2 contain b, index 3 contain b, so on. So now what we are looking for, now we want to find the longest group of the same character. Okay, longest group of the same character that appears continuously. So see here, so let's take, so we can divide it into groups a b b c c. So their length are, a length is 2 2 and 2. So all three groups have length 2, so the answer is 2. Now what is continuously means? See, this is very important for beginners. Let's see this only. So see, the longest group, let's take another example. A B B B C C. Okay, 0 1 2 3 4 5 6. So we have A 2 times, B 3 times, and C 2 times. Okay, so see, the longest group is B, so the answer is 3. Okay, so the answer is C. But see, look at this, A B A. See, a b a, there are two a's. Okay, but they are not next to each other, so we cannot combine them because b is there. Okay, we cannot combine them. We want continuous group, so does not give as a because b is there. So the character must be next to each other, like this. So now comes to the main part. See, so far this is easy, but the start string can change. Okay, but the string can change. This string can change. Okay, so let's see here. S is equal to, wait. S is equal to a b c c. 0 1 2 3 4. Okay, so suppose we are told index 2 and new character is C. Okay, so thus this means we have to go to index 2 and replace the character with there. We have to replace the character with the C. Okay, we have to replace this character with C. Got it? So after it look like this, before we update, before it's look like this, after we update it's look like this, C C C. Okay, so now the longest group is C, so the answer is 3. So the longest group is C, so the answer is, so the answer after this update is 3. Now there can be many updates. Okay, there can be many updates means query. Okay, here see, these are queries. Okay, we have to replace this. There are 3 queries, so b b b c b. We have to replace this b c b with index 1 3 and 3. So see, the problem can give us multiple updates means queries, not just one. So let's understand clearly. String b a b a c c, 0 1 2 3 4 5, and query characters are b c b, and query indexes are 1 3 3. Okay, so see, we have 3 characters in query characters. Okay, we have 3 characters in query characters, so we have 3 queries. We have 3 queries. So let's understand. The problem can give us multiple updates, not just one. So look, let's take this actual example only. Let's put this in table. See, we can make it easier to understand by putting them into tables. So wait, yeah, query is 1 2 3. Okay, index 1 3 3, and the new characters are B C B. Okay, see, the first index goes to with the first character, and the second index go with the second character, and the third index go with the third character. So the queries are: query 1 is index 1 B, query 2 is index 3 C, and query 3 is index 3 B. So let's perform query 1. Where is the actual example? This one there. Query 1. See, in index 1, so we have to replace index 1 A with B. Okay, we replace with B. Now our new string look like this: B B B A C C. Okay, so the longest string is 3. Index 1 currently contain A, so we replace it with B. So after, before it's look like this, after replacing it's look like this. Okay, now we divide into groups: C B A C. So the length of B is 3, A is 1, and C is 2. So the longest group is B, so the first answer is 3. Okay, now query 2 here is something very important. See, for the second query, we content from the starting, we content from the string we got after the first query. Okay, so we do not go back to the original string, we contain this string only. Now we have this string only. So query 2 says replace index 3, index A with C. So we replace this with index 3 na. We like this example: B B B A C C 0 1 2 3 4 5. We have to replace index 3 with C. Okay, now our string will be update. It's look like this: B B B C C C. So the longest length is 3 only. Okay, because B has came 3 times and C has came 3 times, so the answer is 3. Now 3 3. Okay, next query 3, this one. Okay, query 3, this B. This query says replace index 3 with B. Okay, now these are our new string: 0 1 2 3 4 5. Now we have to replace index 3 with B. So there is C. Now we replace it with B. Now our string will be updated. It's look like this: B B B B C C. Okay, see, B. There are 4 B's and 2 C. So the answer is 4. Okay, final answer is 3 3 4. So look at here, the answer is 3 3 4. That's how we get our answer. Now see, so see, we have a string and several queries. Each query tells us to change one character at a specific index. After changing that characters, we look at the entire string and find the longest group of equal characters that are next to each other. So we store that length as our answer for that query. Then we move to the next query and repeat the same process. Okay, change one character, find the longest consecutive group of the same character and store its length, and repeat for every query. That's it. Okay. Okay, now we understand what the problem is asking, but there is one problem. What if the string is very large and we have a lot of queries? So if we scan the entire string after every single query, that can be become very slow. So now let's first think about the simplest solution, understand why it is slow, and then we will see how we can make it faster. Okay, see now let's clear this. Now that we have understand the problem, let's think about the simplest way to solve it. Whenever a query change one character, we can simply scan the entire string and find the longest group of consecutive equal character. So yes is equal to A B C C 0 1 2 3 4. Okay, see, suppose index 2 will replace with C. Okay, after the update our query string become like this CCC. So see, now we can scan from left to right. A length is 2 and C length is 3, so the answer is 3. Okay, see, how do we do this for every query? After every query we repeat the same process. Query 1, change characters, scan entire string, find large group, store answer. Then query 2, change entire means change characters, scan entire string again, the find longest group again, and so on. It's follow the same. Okay, now why is this is a problem? See, this approach is easy, but there is a problem. What if the string has 100k characters and we have 100k queries? For every queries we scanning the whole string, so roughly it's look like 100 queries into 100 characters. What that's about 10 and 0 0 0 0 0 0 0 0 then 0 0 0 operations. Okay, so for it was too slow. So instead of checking the entire string after every update, can we somehow remember useful information about different part of the string? If one character change, maybe we only need to update the information around that position instead of checking everything again. So, and this is where segment tree comes in. Okay, to do that efficiently we can use a data structure called a segment tree. Okay, now see, so let's solve this problem in simplest possible way. S is equal to A B B B C C 0 1 2 3 4 5 6. Okay, so the groups are A B B B C C. Okay, the groups are, so the longest group is B, answer is 3. So now see, now we get a query. Suppose the query says index 0 and character is B. Index 0, new character is B, so we have to update index 0 with B. So see, this means we go to index 0 and replace A with B. Okay, before it's look like this, after replacing it's look like this B A B B B C C. Okay, now we again check the group starting from left. See, again we check the group starting from left. Now B has one time, A has one time, this B is 3 times and this 2 times. I think it's 4 B. So the answer is 3. Okay, now see, Now suppose the next query says index 1. Okay, let me write this b a b b b c c 0 1 2 3 4 5 6, index 1 and new character is b. Okay, so we have to change index 1 with b, there is a, now we have change with b. Now the longest length is 1 2 3 4 5, b length is 5 and c is 2, so the answer is 5. Okay, so see what is the problem. Our method is very simple. After every update we scan the entire string again. For our tiny example, that's completely fine, but imagine if there are string is 100k, okay, characters and queries are 100k queries. For every queries change one character, scan 100k characters, find the longest group, and we repeat this 100k times. So we are doing a lot of unnecessary work. Okay, see, suppose our string is a b b b c c. Okay, we can think of it as a segment. See, a b b b c c. The information is a longest is 2 and b longest length is 3 and c is 2. Now if I change one character, do I really need to forget everything? No. See, for example, if this character change, only the part range connected to that position can change. So instead of scanning the entire string every time, we want a data structure that store information about different range of string. Okay, so and that is exactly the idea is behind a segment tree. Brute force check the whole string after every query. Segment tree help us update only the affected part and quickly get the answer. Now let's see. So before writing any code, let's understand what a segment tree actually stores. S is equal to a b b. Okay, so our index are 0 1 2 3. See, now we divide the string into two parts. Instead of looking at the whole string at once, we divide into two parts. Okay, so it's look like this: a b b, divide like this: a b b. Now a b b. Okay, see, a segment tree keeps dividing the array of the string into smaller range every until range contains just one element. But what to do we store? See, this is the most important part. For every segment we do not just store the characters, we store useful information about that segment. For each node we need left character, right character, and prefix and suffix and best. Okay, see, do not worry, let's understand each one with a b b. Okay, so first is left character. See, left character a left, ch character a. So the first character is a. Okay, so left character is a. For b b, left character b. See, for b b, left character b. Easy na? So see, now right character a. For a, the last is also a. For right character, the last is also a. And for b right character, for b is also last character. Okay, so the last character is b. So a left 0. See here, a left is a and right is a. b b left is b and right is b. Okay, so prefix, see, Now prefix. Now this we have understand. Prefix. This sound difficult, but it's actually very simple. See, prefix means how many same characters are there continuously from the beginning. See here, yeah. Starting from the beginning, both are yeah. So now our prefix is two. And let's take another example. A B B. Starting from the beginning, a only has came once, so our prefix is 1. Okay, let's take one more example. A B. Okay, so from starting from the beginning, a has came 4 times, so our prefix is 4. Okay, now let's understand what is suffix. Suffix means how many same characters are they continuously at the end. Let's see, a b b. Okay, so the at the end there are bb, so our suffix is 2. Okay, and let's take one more example. Suffix is 2. Let's take a b b c. Okay, c. So the last character is suffix is 1 because there is only one character. Okay, see, best e. Now we have understand left, right, prefix, suffix, and now it's best. Okay, see, best is longest group of the same character everywhere inside this segment. Okay, inside the segments a b. Let's stay right, a b b. So we have a b b. Both length is 2 2, a length is 2 and b length is 2, so the best is 2. Okay, so we have, if we have a b b b, a has came 2 times and b has came 3 times, so our best is 3. Got it? Now let's put everything together. Left character a, right character b, and prefix x2 and suffix x2, and the best is 2. Okay, now comes the important idea. Suppose if left is a and right is b b b, so if we combine them, see, if we combine them, a plus b b b, so the answer is 3. But suppose if a left is a and right is a, now if we combine this, a plus a, so the answer is 5. The two segment connects because left end with a and right end with a, so left suffix plus right prefix, 2 plus 3 is 5. Okay, so this is a main reason we store prefix and suffix. So why we are storing prefix and suffix? Because when we combine two segments, a repeating group can cross from the left segment into the right segment. If the left segment ends with the same character that the right segment start with, we can join those two groups. Okay, let's take a. Okay, there are two groups. If we add this, it's become one group. 1 2 3, the answer is 5. Okay, left suffix is 2 and right suffix is 3. 2 plus 3 is 5. See, the complete idea is, so each segment tree notes remember what character start here, what character end here, and how long is the same character group of the beginning, and how long the same character group at the end. So what is the longest group everywhere inside? Okay, that's it. So then then when a character change, one character change, update its small segment, merge its parent, merge the next parent's root, give the answer. Okay, now we know, see, now we have two segments. We need to combine their information and create the information for their parents node. This process is called merge. Okay, this process is called merge. Suppose left is a and right is b b b. Okay, so the tree A B B B. Let's divide A B B B. Okay. See. Left to first A. So this will not press dot left character is equal to A dot left character. See, the first character of the parents come from the left child, and right character parent, the last character B. So the last character of the parents come from the right child. So left A prefix is 2 and right B B B, so the suffix is 3. See, string is same characters, string has same characters, so parents prefix 2 normally. See, but sometimes prefix can grow. Suppose left is equal to AA and right is equal to AAB. Okay, we combine them, AA plus AAB, AAB, so the result become AAAB. Okay, so the prefix is 4. Why? Because left end with A and right start with A. Actually left segment is entirely A, so its prefix can connect with the right prefix. So therefore how we write, if A dot left character is equal to A dot right characters and A dot right character is equal to B dot left character. So reversed or prefix equal to A dot prefix plus B dot prefix. Okay, so see, if the entire left segment contains the same character and that character is also the first character of the right segment, the prefix can extend into the right segment. So suffix, same idea but from the right side. Okay, now for suffix the same idea, no, but it for right side. Suppose left is equal to A B B and right is equal to B B. So if we combine them, it's look like this, and at the end suffix is 4. Why? The right segment is completely B and the left segment end with B. So we write, how can we write this? If B dot left character is equal to B dot right character and A dot right character is equal to B dot left character, result dot suffix equal to B dot suffix plus A dot suffix. Okay, so see, now we write best, most important. Now best, suppose left is equal to A and right is equal to B. Last best is 2 and right best, last best is 2 and right best is, left best is 2 and right best is 3. So how will I res dot best equal to max A dot best and B dot best. Okay, means max A is 2 and B is 3, so the answer is 3. Okay, see, but there one more possibility. What if the longest group close the middle? See, for example, left is equal to A and right is equal to A. If we combine them, it's look like A. Okay, so left suffix is 2 and right suffix is 3. If we combine them, 3 plus 2 is 5. So how can we write this? If A dot right character is equal to B dot left character, S dot best is equal to max and S dot best A dot suffix plus b dot prefix. Okay, if the left segment end with the same character that the right segment start with, the two group can connect, so we check left suffix plus right suffix. Okay, now we have to merge. See, imagine parent, left and right. Okay, so see, we check parent's first character left first. Okay, parent last character right last. So prefix can left prefix extend, suffix can right suffix extend, base left base right base cross. Let me write this. Okay, parents first character left first. Okay, first, and second is parents last character right last. Third is prefix can right prefix left. Okay, prefix is left, prefix extend, prefix can left prefix and extend, and fourth suffix can right suffix extend. Okay, so best is just a minute. Best, left best, right best, cross left suffix plus right prefix. Okay, see, the one things you really need to remember: do not try to memorize code, just code. Okay, remember this: left segment, right segment, suffix, suffix press prefix, then can they connect best. Okay, see, that's the heart of the LeetCode problem 2213 segment 3. Now the most important part, see, now we have already know that every segment tree node store left character, right character, prefix, suffix and base. Now we need to understand how two child nodes are combined. So let's take small example. So suppose we have string is a b b b, so we divide into left is equal to a and right is equal to b b b. Okay, so our tree look like this: a b b b, a b b b. We already know the information for both children's left a wait, left character a, right character a. Okay, now prefix is 2, suffix is 2 and best is 2. For right, we know right character b, left character b for right, and right character b. So prefix is 3 and suffix is 3 and the best is 3. So now we need to calculate the information for a b b b. So that's how we merge those. So see, now we find left character. See, the parent start with whatever the left child start with. Okay, left is equal to a, this a. So let's dot left character is equal to a dot left character. See, the first character of the parents come from the first character of the left child. Now we find right character. See, right B, this one. Okay, so how can we write? Res dot right character is equal to b dot right character. Okay, the last character of the parent comes from the last character of the right child. Now we find prefix. Remember, prefix is how many equal characters are continuously present from the beginning. Okay, so say for a b b b, so we have a2 and b3. From beginning prefix is 2. Okay, but there is an important case. Suppose if left is equal to a and right is equal to a b, we combine. Actually a press a b, a b. Okay, now the prefix is 4. Okay, now the prefix is 4. Why? Because the entire left segment is a and the right segment also start with a. Okay, see the I think I have to write a code. If a dot left character is equal to a dot right character, and a dot right character is equal to b dot left characters, res dot prefix equal to a dot prefix plus b dot prefix. Okay, so the whole left segment is the same character and the right segment start with the same character. Now we have to find the suffix. See, suffix means how many equal characters are continuously present at the end. So example a b b b b, at the end there are 4 b's. Okay, so the suffix is 4. If suppose what left is equal to a b b and right is equal to b b, so if we combine this, our string become like this, b b. Okay, so the suffix become 1 2 3 4. Okay, now see, we can combine the left suffix and right suffix. How? If b dot left character is equal to b dot right character and a dot right character is equal to b dot left character, res dot suffix is equal to b dot suffix phrase and a dot suffix. Okay, sorry for this code. See, now we have to find best. So this is the most important one. There are 3 possibilities of the best answer. Possibility 1 is best is completely inside the left child. Okay, see, left is equal to a b b. Okay, maybe best is 3. So possibility 2 is best is completely inside the right child. Right is equal to b b b b c. Maybe best is 4. So first we write res dot best dot max, a dot best and b dot best. Okay, see, and the possibility 3 is the best across both children. This is the special case. Suppose left is equal to a and right is equal to a. Together its left suffix is 2 and right prefix is 3, so they have the same character, so they connect, it's become 5. Okay, so for this case we write if a dot right character is equal to b dot left character, res dot best dot max, res best a dot suffix plus b dot prefix. Okay, so merge is basically doing left right merge parent. Okay, it's asked what if my first character, what is my last character, how long is my starting rope, how long is my ending rope, what is the longest rope anyway. Okay, So the key idea is the most important line to understand is, see, a dot suffix plus b dot prefix. Imagine left is equal to a and right is equal to a. So see, at the boundary same characters. Okay, we joined 1 2 3 4 5 6 7. If we join this, it's become 7. See, left suffix is 3 and right prefix is 4, so 3 plus 4 is 7. That's why we store prefix and suffix. So the reason we store prefix and suffix, when we combine two segments, the longest repeating group might cross the boundaries between them. If the group left segment end with the same character, the right segment start with the suffix and prefix can be joined. So the best answer for the parents can come from the left child and right child, or from the combination of the left suffix and right suffix. Okay, once the merge logic is clear, the actual code becomes much easier because every line of the code is implementing one of these simple rules. Okay, now let's create. See, first we have to create the nodes. First we need a structure to store the information we just run. Okay, wait. Structure structure node character left character and IGST right character int prefix int suffix and int best. Okay, so it was clear. We know why we need this. Okay, first I will create node. First I will create a node structure. Every node represents a segment of the string and it stores 5 pieces of information. Left is left first character and right for last character, prefix for same character from the beginning, suffix for same character from the end, and the best for longest repeating group. Okay, so we know this, why we are writing this. Wait. See, for example, a b b. So we could have left character a and right character b, prefix is 2, suffix is 3, and the best is 3. Okay, so why do we need a segment array? See, now we need to store all these nodes. Okay, now we need to store all these nodes. your vector int, it's what node, not int, node tree. Okay, but we need enough space for the tree. REE. See, a common implementation is tree dot resize 4 into n, so where n dot n is equal to size a string dot size. So let me write here. N is equal to s dot size tree dot resize 4 into n. Okay, a segment tree contain multiple nodes, so I need an array to store those nodes. I allocate around 4 times the size of the string, which is enough for a standard segment tree implementation. Now we build a tree. So now we need to create the tree from the string. We will use it's perfect. We will use void build and node and left and right. Okay, so do not worry about three variables here. Node means which tree node are we working on. L means left boundary of the segment, and right R means right boundary of the segment. Okay, see, for example, it's look like this. So our string is this: build 103. Okay, so me start at the tree node and handle the string range from index 0 to index 3. Handle the string range index 0 1 2 3. Let's take small example, cut this big. Okay, index 0 to string index 3. Now we have to find ref node. Eventually the range becomes one element. See, for example, left is equal to 0 and right is equal to 0. Remaining, that means string of 0 is a. So this is a ref node. We write, how can we write? If left is equal to right, tree node dot left char equal to string of left with boundary dot right is equal to s of left v dot prefix is equal to 1 and dot suffix is equal to 1. So best is equal to 1 written. Okay, see, if left and right are equal, it means our segment contains only one character. For a, so there is left character is a and right character is a, and prefix is 1, suffix is 1, and the best is 1. So that's why every value is easy. Okay, now we have to divide the segment. If we have more than one character, we divide the range into two halves. Okay, so how can we divide? In made, let's divide here. And made is equal to int left less right divided by 2. Okay, so then build node into 2 left mid and build node into 2 less 1 and make less 1, then right. Okay, see, look, see here, for B, B, 0, 1, 2, 3. Okay, so we divide 0 to 3. 0 to 1, 2 to 3. So here A, B, B. Okay, see, left child node into 2, right child node into 2 plus 1. Okay, now we have to merge the childrens. After building both childrens, we need to combine them. That's why our merge function comes. Okay, tree node equal to merge merge tree node into 2 tree node into 2 plus 1. Okay, once both children are ready, I merge them to calculate the information of their parents. Now build now so our build now look like this. Our build look like this. Okay, yes. See, I have do not memorize this yet. Just remember the flow. Build. This is one category. Yes, store information. No, split into two halves. Build left, build right, and merge them. Okay. Now we already know merge has to do left node press right node parents. Now function of merge node merge. Now I think I have to write here only node merge node node B. Node. Okay, see, the merge function takes two nodes, and the left node and the right node. Okay, so then we create a new node called res for the parent. So it's look like this. A is equal to left child, B is equal to right child, and RZ is equal to parent. Okay, so first character we run that the parents first character comes from the left child, so that we write res dot char is equal to a dot left char. Okay, see, for example, a is equal to a, b is equal to b, a dot left character is equal to a, so therefore res dot left character is a. See, the first character of the parent is the first character of the left child. Now last character, same for the last character. I feel like b dot right character is b, so therefore res dot right character is equal to b. Similarly, the last character of the parent comes from the right child, so let's write res dot Okay, now we have to start with the left prefix. Normally the parents prefix come from the left child. Prefix, so it's look like this. Say a is equal to a and a dot prefix is 2, so res dot prefix is 2, but sometimes the prefix can extend into the right child. So when can prefix extend? See, a is equal to a and b is equal to b, a b. Okay, so together a b, it's become the prefix is this. Okay, a 4. So the prefix is 4. Why did it extend? Because a is equal to a, it's completely made of a and b start with a, so we check. So we check if a dot left character is equal to a dot right character and a dot right character is equal to b dot left character, then res dot prefix equal to a dot prefix press b dot prefix. Okay, so let's understand the condition. See, first condition is a dot left character is equal to a dot right character, mean for a is equal to a. So we have a is equal to a, true. So this tell as the entire left segment is one repeating character. Second condition is a dot right character is equal to b dot left character, means for a is equal to a and b is equal to a b. See, so we have a is equal to a, it was 2, so we can connect them. A dot prefix plus b dot prefix, 2 plus 2 is equal to 4. Okay, so suffix, so we start with suffix because normally the suffix come from the right child, but if it can extend into the left child, say a is equal to let's take this example, a b b and b is equal to b b, together it's look like a b b b b. Okay, so the suffix is b b b. So we check. Equal to b dot, so we check if b dot left character is equal to b dot right character and a dot right character is equal to b dot left character. Let's start. Suffix is equal to b dot suffix less a dot suffix. Okay, if the entire right segment has the same character and the left segment ends with the same character, the suffix can extend. Okay, now base, now is the most important part. See, for the first best could already be inside the left, a dot best, or inside the right, so b dot best. So res dot best, so right res dot best is equal to max a dot best, then b dot best. Okay, so then best is 3. Checking the boundary, see, but there is a third possibility, the longest group could cross the boundary. So we have just know that. How can we handle this? If a dot right character is equal to b dot left character s dot best is equal to max, and res dot best a dot see. Finally we check if the group cross the boundary. If the left child end with the same character, the right child start with, we can combine the left suffix and right suffix, then last we just return the answer. So see, now just write everything. See what we are doing here. So remember this, okay? Parent left right, left character is equal to left and right character is equal to right, so prefix is left and suffix is right, so best is equal to left best, right best, or left suffix plus right prefix. Okay, so that's the entire merge idea. Now let's try run. Okay, so we will use the small example. S is equal to a. Okay, index was 0 1 2 3. Say the segment tree divides it like this, a. Okay, so we are going to merge these two a nodes. So left its information is left character is a, right character is a, left character is a and right character is a, and the prefix is 2, suffix is 2, and the best is 2. Okay, so think a both a. Now information for right, a left character is a and right character is a, prefix is 2, suffix is 2, and the best is 2. So see, now left character in our code I have right, where is that line? See this line. Okay, left node start with a, so left character a and it's point to a. Okay, this line is point to a, so right character right ends with a. Okay, so it's point to last a, it's left point here and right points here. So now we check, so we will check if say we are checking, let's replace the value. First condition, if left character is equal to a, see here, if first character a is equal to a, it was true. So the second condition, right character a right character is equal to b left character, so a is equal to a, true, both are true, therefore prefix we place this line. Okay, this line. So 2 plus 2 4. Okay, so the length is 4, then suffix is 2. We check, see, we check b dot left character, suffix we check b dot left character, a is means a is equal to a true, a is equal to a true, so the answer is 4, suffix also 4, and the best is 4, so the best is 2. See, a dot best is 2 and b dot best is 2, so max 2 2 2, but we have not finished. We need to check whether the best group cross the boundaries. Okay, it will cross the boundaries. So here we check a right characters is equal to left characters value, it was true, then 2 plus 2 4, so the answer is 4. Okay, that's all. So see, so the left child is so the left child is a and the right child is also a. Both children have a prefix of 2 and suffix of 2 and the best value of 2, because the right child ends with a and the right no and the because the left child end with a and the right child start with a, so these two groups can connect, therefore the new prefix become 2 plus 2 and the new suffix become 2 plus 2 and the longest group also become 2 plus 2, which is 4. So the parents note represent a as told prefix and suffix 4, the best answer is 4. Okay, that's all. I think so. Let me clear this. See, remember our problem, a query tell us to change one character at one index. So string is equal to a b b. Suppose the query is index 2 and new character is a 0 1 2 3. So before it's look like this, after we change index 2 with a, it's look like this 1 1 1 a b. Okay, so the update function job is simple. Go to the index, change the character and update the segment tree. So first we write the function. Okay, we have to write the function. I think I have to write full code first, then it was easy to explain. So let me write first full code, then I will explain clearly. Okay, just a second. Structure node, then I have to write string s new node, where is merge node? I have not written a merge function. Node merge node A. Let me first write the clear code, okay, then it was easy to explain. Okay, node left. Where is dot? I have right here. Merge function I have right here only. Then if first let fix me this incorrect position, then I think what is a mistake I have done. I have written this also. If left character B, right characters and here out P as a suffix, then where is this? I have to close this here only, but I have not chosen, and command C, then command V, then if I think yes, country, then if a right character will be, so just a second. Then here we just return the RD. I have to here only I have to RD and return. Yes. Okay. Now next is build function. It's the code. Now build function. In this we have passed node left and right. That much is right. So and then we have find a mid. Test mid. In I find mid, then 3 node merge with 2 and to press 1, it was right. So the flow we have to add an update function also. Void update update and node and left and right and idx and c. So if left is equal to right, if left is equal to right, then we just do this, call the function renode dot left character is equal to c and currently dot I just write character is c. I think have write update function. No. Character C. So prefix is one, and then I read prefix is one, suffix is one. Let's see. Yes, command V. So then int made is equal to left press right that was divided by 2 if id x is less than or equal to made update if made node into 2 plus 1 made press 1 then write id x and c. Okay, it was clear. Then we to here command c command tray is equal to merge v 3 node, I think node into 2 3 node into 2 plus 1 so it was clear. Then index queries this s is equal to s and n is equal to s dot size three dot size is 4 into n build 1 0 n minus 1 vector int again as answer. So a loop for int I is equal to 0 then I is less than I is less than queries dot indices dot size. Okay, then I plus and id x is equal to indexes of I, then ch of c is equal to character of I update 1 0 n minus 1 id x c. So in last we just push the answer dot push back 3 of 1 dot best in the start return a n s. Oh, finally it's finished. so it's yes, it's good. First structure of node, then tree, then we must store left and right if the character of a, then suffix plus prefix, then if character for b dot left scrolls, then rest if a answer, then we build a function of made. I find made, then update for white, done. Then we calculate made. I think I calculate made, then I put else. Update, else we have to update a tree node also. I think I have missed anything. What was that? Else no, update, I have calculate made, then if mate is less than or equal to node to I think that mistake from here only. 1 2 left made id x and save. Okay, then I'll update. Node into 2 plus 1 make less 1 write id x and c. Still I'm missing anything. These are set as a non-static member function. Can I do fix? It's very hard. hard, not so pretty hard. I think so. Wait, let's do right now, then we get clarity. Okay, so we have this example, and index 2 we have to replace with a. So before it look like this, after it look like this, a. Then see, so the update function job is simple. Go to that index, change the characters and update the segment tree. Then this function, it is that function void update this. Okay, see there are 5 things: node, current tree node, left boundary, right boundary, and index we want to change, and new character. Okay, there are 5 things. So see, eventually we reach if left is equal to right, that means this node represent exactly one character. So one character, so we write this. Okay, suppose see index 2 is b, so we want index 2 with a, so the leave of original store b and update with a. So since there is only one character, left character a and right character a, prefix is 1, suffix is 1, and best is 1. Okay, which side should we go to if we do not have reached the leaf yet? So we split the range. So see, int mid is equal to left press right divided by 2. Now see, is the index I am looking for on the left side or the right side? If index is less than or equal to mid, then the index is in the left child. Okay, so we update this line. See, we update. Okay, so suppose if we update, then suppose if a b b, so 0 1 2 3, 0 to 3 and 0 to 1, so 2 to 3, a b b. Okay, so we want to update index 2. So mid is 1. Now mid is equal to 1, so 2 is less than or equal to 1. No, so we go to right. So we go to right. So 2 is equal less than or equal to 2. Yes, so we go to left. Now b is a. Okay, so after updating the leaf, so this is very important. See, we change only one leaf, so but its parents may not have different information, so we need to merge again while coming back this line. We merge them coming back. Okay, so after changing the characters, the information stored in its parents by become outdated, so we merge the two children again and recalculate the parents. So and this continue all the way to root. So this is a complete function. See, query, remember this query: which index, go down the tree, find the index, current, change the characters, come back upward and merge. Then root is update. Okay, so the root contain tree of 1 that was best, which give as a current longest repeating substring length. So see, we do not rebuild the entire tree. If 100 case character, if one character change, we only travel from the root to that character and update its against. Okay, so that's why segment tree is efficient. The height of the segment tree is approximately big O of log n. Okay, so one update is big of login and getting the answer is 3 1 dot best. So which is big of 1? Okay, so we have run already, run each part separately. Node, merge, build, update, and process every query. So let's see here. Before building a tree, we need to decide what information will one tree need to store. So this is that. Okay, this information we need to store. So see, left character is left character first character, and right character is last character. Prefix is same character from the beginning, suffix is same character from the end, and the best is longest repeating character. Okay, then we have create a string variable. Okay, so we need somewhere to store the segment tree. We need somewhere to store a segment tree. So why string s? Because build needs to know the original character. Okay, so then merge. See, now that we know what a node contains, we can write the function that combine two nodes. Okay, then these lines, then prefix, suffix, then best. Okay, so finally in last we just return rest. Then we write build function. Now we know how to merge nodes, so we can build tree. So we handle the single character case. Here we are handling the single character case. Then we divide, we build. Here we divide, we build left, we build right, then we merge, then we close. Okay, here we close. So here update. See, now the tree exits, the query will change one character, so we need this. First if we reach the exact index, then we calculate mid, then we choose left or right, then we merge again. Okay, here we are merging again, then here we are choosing left or right. So that's all. I have to fix this. Yes. I think two. So let's see what is my mistake. F right is, then we have vector tree string s. Structure node H prefix is best. It was finished. Then I have created notary for a string to store. Then merge. Then this is character at the left and right boundaries, and prefix start prefix if prefix mistake. Left we store left and it is 1. So the code is right, but yes, string. What is the issue? Wait. It was right. Sorry. I have tried this here, but the code is right. Oh, I am checking what is wrong. So a test case, which test case? E. files are this? Let's check. Go to left. Less than or equal to right. If we adopt character and without if a dot prefix is equal to a dot len and a dot right equal to b dot b dot is the effect so this left character, right character, then we do prefix, suffix with our class, and I have best and random. So string and merge node A and B, ordinary, the total length is length plus B is length, yes it was total, boundary check, then prefix, okay, boundary check, start A, so let's start. I'll just not give this. Sure. Create now suffix, if a suffix then suffix, yes, in last we just written the best A or B. See, the main logic mistake was in merge in here. So this, to decide whether the whole fit segment had the same character that not significant. For example, ABA has the same first and last character, but the whole segment is not the same. Okay, so we add int length, and now we check a prefix is equal to a length. So this correctly means the entire segment a constant of the same character. Okay, so the important fix was not just a syntax issue. The merge logic was also wrong, which is why some test cases pass by hidden case field. Yes, that's all. Sorry, it took a little long time, but so that's all. Yes. So let's revise one last time. So we have a string, for example, BB. Then we have get some queries that change one characters. After every change, we need to find what is the longest substring containing only the same characters. So why do we need segment tree? If we check whole string after every query, it's can be too slow, so we divide the string into segment using segment tree. For every segment we store for only a few things: left character, first character of the segment, right character, last character of the segment, prefix same character from the beginning, suffix same character from the end, best to wrong same character substring inside the segment, and len means length of the segment. Okay, so that's all. Build a segment tree, store prefix, suffix and best, update one character, merge back to the root best is the answer.